I'd like to talk about evaluation of skill improvement by combining skill and difficulty level during paper cutting production. Many artworks have two stages, draft and production. This paper is concerned with the stage of production in the artwork, and we focus on the production of paper cutting as one of the artworks. In the stage of drafting for paper cutting, the artist drew a picture painted in black and white color, and in stage of production, the artist cut off the unnecessary parts with a knife. We are studying skill improvement for paper cutting. In previous research, we have acquired the skill to control pressure as an expert. We have quantified the difficulty level of a simple pattern based on the steering law. In this paper, we quantitative analysis of the combination of skill and challenges essential to the flow state in field of psychology. We made a cutting device to measure cutting pressure. A blade is attached to the tip of a stylus. This stylus is for drawing display and has a pressure sensor. User cuts the paper on the drawing display with our knife. Our system can measure pressure, coordinate, and cutting time. We define the width that the knobs can easily cut as 30 mm and set the narrow width as 5 mm. Feature, we made 10 different patterns using combination of 5 width value and 2 distance value. We calculated the ID is distance divided by width value. We have developed the system evaluate the cutting based on the pressure range of controlled by the expert based on the result of experience. The pressure range of the expert was from 250 to 350 grams. The user cuts the paper on the tablet display with a knife device. The system measures the difference between the pressure range of experts. The display shows the result of the evaluation in color and sound alert. The user control applied pressure. We developed a system to measure the ID and determine the target distance and width of each target based on the coordinate of the boundary. The large distance is the sum of the small distance between the coordinates. The large width is the average of twice the value of small width. Our system measures different difficulty level of each cutting line. We have measured three types of picture based on the width of the target. This table shows the frequency distribution and average value of the ID. The narrower the width of the line consisting the picture, the higher the average ID and the lower the width, the wider the average ID. Furthermore, the maximum value of the ID in the frequency distribution were higher for pictures with a narrow width and IDs distributed over border range. Hence, we confirm that the ID tends to increase the narrower the line. Also, the difficulty of picture is not a unique value. The flow state is connected to the performance in a situation where personal skill equals the required challenge. In this study, we assume that skill to control cutting pressure is a skill, and difficulty with high practice effect is a challenge. We evaluated the consistive factor of flow state in the production stage of the paper cutting by creating the flow state scale FSS for paper cutting. The participants answered a questionnaire consisting of 36 items on a 5-point scale. The participants were 40 novices. We measure the pressure and time when the participant cuts the paper. The participants perform the tasks. Step 1, some group cut picture A and the other cut C 5 times. Step 2, all groups practice using the picture B with or without the pressure presentation system. Step 3, all the group repeated step 1. Step 4, They answer the questionnaire on the paper cutting FSS about the production in step 3. In step 1 and 3, Group 1 practice picture A with our system, Group 2 practice C with system, Group 3 practice A without system, Group 4 practice C without system. This graph shows the factor score in FSS. The first factor means balance between skill and challenge. The effect size of Group 1 was more significant. There was no significant difference between Group 2 and Group 3. Additionally, Group 4 was significantly lower than the other groups and only showed a factor in a negative direction. In the second factor, means concentration on efforts. Group 3 and Group 4 show a negative factor. In the third factor, change in sense of time. Group 2 and Group 4 show a negative factor. We found Group 1 show a higher effect size compared to the other groups. This paper aims to analyze the improvement of skills for production activities and the flow states of user by the combination of skill and difficulty. From our assessment, we confirm the highest skill improvement effect and flow state when the novices who practice using our system for pressure control produce design using high difficulty design.